Everybody, this is our presentation of our project. Our group is Group 7. My project is reinforcement learning based on an interactive game. This is our team members. Mm, so the aim of project is to build a scuba game in Unity with two levels of difficulty. In easier version, one agent pushes a box to the target area. In more difficult version, three agents cooperated to push three different sides of blocks into targeted area. The objective is to train a single and multiply agents use different reinforcement learning like DQM, PPO, SAC, and so on, and evaluate their strengths and weakness. This is our Unity environment development. This is our training video. You can see the Unity environment for Scuba game was developed by building agent boxes and target area. For the game, uh, the ground and four walls were built using Unity Cube object to enclose a square area and limit the agent's movement range, and all objects in environment were set as rigid bodies with collision detection mechanisms to allow them to operate realistic. To accelerate the training speed of reinforcement learning, 32 identical training scene was set up for the single agent, and four identical training environment was set up for the three agent push boxes game. In three agent push box block, which require agent have teamwork ability, and because the block labeled 2 and 3 must need 2 or 3 agents to push respectively. C# code was written for each object to set their basic motion logic and parameters, behavior parameters that could be captured by reinforcement learning model for training process. Um, this is our system architecture. The Unity ML agent toolkit was used to facilitate training and interaction between the DRL agent and the Unity game environment. The Unity environment sends the state information to the agent and the RL algorithm, which the agent uses to select actions and send them back to the Unity environment to affect its state. After each action performed, the Unity environment sends state information and reward signal to the agent and the RL algorithm to respond to the change in the environment. This is our data definition. The agent is push boxes solver, and the environment is game scene including ground blocks and target area. The actions is discreted, which has 7 move, direction, and distance. The states contain the current position of agent blocks and the target area. The reward, a high reward 5 for successfully pushing the block into the target area, and a negative reward negative 0.01 called step penalty for each action the agent tasks. This is our algorithm implement. Which has a DQN, PPO, SAC, DDPG, and POCA. Each algorithm has its own strengths and weakness. DQN uses a neural network to approximate a Q value, and a PPO is an all-policy algorithm that optimizes the surrogate object using gradient descent. SAC is also a off-policy algorithm combines strengths of policy gradient and Q-learning. DDPG is an off-policy algorithm that combines the actor-critic approach, and the POCA deal with properly assigning credit to actions we are taking early in the trajectory. This is our result analysis. The DQ, we will consider four factors: cumulative reward, episode length, and policy loss, value loss. The DQ algorithm did not perform well in the task due to its limitation in address complexity of environment. And the POCA algorithm show improvements over time, but its conversion to the optimal policy may be slower, and the PPO and SAC algorithm show similarity performance with both reaching a stable level at about 1.8 million step size. However, the policy loss of SAC presented a stable downward trend and was consistent less than zero, indicating that it performed well in training and in training policy network of agents. The more details of training result is our presented in our report. So this is our presentation of our project.